Good morning. So we're going to go over Unit 1, Day 5 today, and it's going over composite functions. So it says given two functions f and g, the composite function denoted by f of g, or f is composed with g, is defined by f of g of x or f of g of x. This is when we start with x and we work our way out. So inside to out. So we start with x and we substitute it in for the g and we get g of x. And then we get a number or an expression and we substitute that in for the f, for the x values of your f. And then we're going to get my final f of g of x. So the domain f of g is a set of all numbers x in the domain of g, such that g of x is in the domain of f. Finding and evaluating composite functions. So I know you guys have gone over this before, should be a review. We're going to start with our x. This is going to be the same thing as f of g of x, same thing. You'll see it both ways. We always start with the one closest to the x, and then we will go out or to the left. So we always start with the inward one, and then we'll go out. So I'm going to start with g of x, and then I'm going to substitute it in for any of the x values in f of x, which I only see one, right? So this is going to be f of g is negative 4x plus 1, which is going to give us 2 times, and then negative 4x plus 1, quantity squared, right, because there's a squared, and then minus 3. So this is pretty simple. We're just going to FOIL this. So it's 2, remember any binomial squared, we have to multiply it by itself. So negative 4x plus 1 times negative 4x plus 1, which will give us 16x squared. Negative 8x plus 1. And then minus 3. I have to distribute this 2 first. The order does matter. So I'm going to get 32x squared minus 16x plus 2. And then minus 3. And I know that just becomes negative 1, right? So I'm just going to, oops, sorry. Minus 3. Negative 1. Alrighty. So this is f of g of x. F of g of x. Let's look to see if g of f of x is the same thing. Let's find out. So again, we're going to look at the innermost one, which in this case is f of x. And we're going to substitute that into our g of x. So we're going to do the opposite, okay? So we're looking at g, and we're going to substitute in this whole expression, which is 2x squared minus 3 for any of the x values. So I'm going to write down right here, this is negative 4, and then x, but we know what x is. X is now 2x squared minus 3. And then just don't forget to go back to your original expression. I still have a plus 1. Okay, now we're going to do the exact same thing. Distribute your negative 4. So I'll have negative 8x squared. And then plus 12 plus 1 is plus 13. Are these the same thing? This is g of f of x. No, these are not equivalent. And they usually are not. I don't want to say always, but usually are not equivalent. Okay. So let's look at the domain. To find the domain of f of g, okay, so let's try to find our, I'm going to substitute it in, and we're trying to find f of g. So I'm going to take g, and I'm going to substitute that in for my x values. But first, we need to look at the domain of each of these individually. So the domain of f is, well, it looks like all of x except for when x equals -2, because -2 plus 2 is 0, and we cannot have a 0 in the denominator. So when x equals -2, we'll have an issue. There's no other issues here. So domain of f. Now the domain of g is when x, or all real numbers really, except for when x is equal to +1, right? Because 1 minus 1 is 0. So x cannot equal 1. Now, we cannot have our, we cannot put -2 in for x for our f of x, right? -2 cannot be in here. So we're going to have to set that equal to g to find out what another restriction that g may have. G may have another restriction because the ending cannot be -2. So we're going to say, well, when g of x just can't equal -2, okay? And g of x is 4 divided by x minus 1, so that cannot equal 2. And we're just going to solve. Well, multiply each side by the denominator, x minus 1. Since it's, not 0, this does matter. We have to do this. So this will cancel out. This is going to give us 4, cannot equal -2 times x minus 1. And then distribute your 2. 4 cannot equal -2x plus 2. Subtract 2. And then divided by -2, x cannot equal -1. And that makes sense, because if we substitute -1 in for our x and g of x, 4 divided by -2 is -2. And if we put this into our f of x, -2 plus 2 is 0. So that's exactly why x cannot be -1. So we're going to look at our domain. Our total domain of f of g has a restriction. So it's all of x, except for when x equals, we cannot substitute 1 in there, right? Originally, because of our g of x, we cannot put 1. That would give us 0. Cannot equal 1. And our x cannot equal -1. Any other number would work. Okay? So this is the domain restriction of our inner function. This is our g of x. And then this is our domain restriction of the outer function, right? If you substitute -1 into the g of x, we'll get -2, which won't work for the f of x. Alrighty guys, go ahead and go to the next page. We're going to look at the domain and range of f of x and g of x. So if we're trying to find the domain and range of this composite function, remember what we did in the last problem, okay? And then they want us to sketch it. So this is example 3, 2 divided by x plus 4. My domain looks like it's going to be everything except when x equals -4, because I'll give a 0 in the denominator. So x cannot equal -4. And our range, you're going to have to graph this maybe in your calculator. It looks like our y values are everything. It looks like the degree of the numerator is smaller than the degree of the denominator. So remember our rule, our asymptote will be y equals 0. So y cannot equal 0. But it looks like everything else will work in our range. All right, f of g of x. Well, let's do our g of x. Our domain x looks like you can substitute any number in for x. So x is a real number. Or you can do negative infinity to infinity. And then our range for the g of x is just a straight line. So this is also going to be all real numbers. Alrighty, I am going to find f of g of x, which is 2 divided by, instead of x, we're going to substitute in g of x, so that'll be x minus 1, and then plus 4. And that just gives you 2 over x plus 3. And then I'm going to do g of f of x is, we're going to substitute the 2 divided by x plus 4 in for the x. So we're going to have 2 divided by x plus 4, and then we have the minus 1. So our g of x, it looks like we cannot have a negative 4 here, right? We cannot have negative 4. So I'm going to have to set that restriction on g of x. Our g of x, g of x cannot be negative 4, because when we substitute that in for the f of x, that won't work out. So when is g of x equal to negative 4? G of x is x minus 1. When is x minus 1 equal to negative 4? Because this cannot happen. I'm going to add 1 when x cannot equal negative 3. X cannot equal negative 3. Perfect. It matches, right? This won't work. And it wouldn't work. So x cannot equal negative 3. So my domain for this is going to be all real numbers except for when x is equal to negative 3. And my range is still going to be y cannot be 0. Okay? So we'll go over graphing this in a second. Let's look at our other side, g of f of x. So we have 2 divided by x plus 4 minus 1. So our domain restriction is going to be when our x value is negative 4. Right? And our range is y cannot be negative 1. Let's look at that. So you guys already know that the degree of the numerator is less than the degree of the denominator. And then so your usually your asymptote would be y equals 0. However, they're shifting everything down 1. So this is why our asymptote is actually going to be down here at y equals negative 1. And then our other asymptote is going to be when x equals, it says negative 4. It's not going to be able to touch negative 4. So our function would probably look like this. You'd have to test some points to check it out. Make sure. Now this one, it says our domain, there's going to be an asymptote right here at -3. X equals -3. And our range would have an asymptote at y equals 0. And so our graph would probably look like this. You can graph on your calculators, check it out. Alrighty guys, I'm gonna try one more with you. Just remember that holes will occur. There will be some holes when the domain restrictor of the inner function and the restriction of the outer function. So let's go over one. Let's look at this domain is going to be all the values of x except when x equals 1. I cannot input 1 into this equation. And my range, if you look at this, the degree of the numerator is equal to the degree of the denominator. So there will be an asymptote when we look at the leading coefficients of each one. So 3 divided by 1, there will be an asymptote at y equals 3. So my y values, all y's except for when y equals 3. Not okay. Now let's look at g of x. My domain is all values of x except for when we have the denominator is equal to 0. So when our x equals 0. And my range is all values of y. The degree of the numerator is less than the degree of the denominator. So that's when we have an asymptote when y equals 0. So y cannot equal 0. Alrighty. So I'm going to actually just input the g of x into the f of x. So I'm going to take the 2x and I'm going to substitute it in anytime I have an x. So this is going to be 3 minus 5. I just do it this way so I don't forget anything. And then my g of x minus 1. And now I'm just going to input g of x. G of x is 2 over x. So 2 over x and then 2 over x minus 1. What we do to get rid of x's in the denominator is we're going to multiply the top and the bottom by x. And we do this often. I know you guys have seen this in Algebra 2 to get rid of the denominator. So I'm just going to show you this is simplified. This is 6x or 6 over x minus 5 divided by 2 over x minus 1. I'm going to multiply the top and the bottom by x. Ooh, sorry. And then this gives me 6 minus 5x divided by 2 minus x, right? All right, and there is still a problem with the denominator. There's still going to be a restriction on the domain, and this is when x equals 2, positive 2. Okay, let's look up here and do this one. So I'm going to find g of f of x. So I'm going to take my f of x and substitute that into my g of x. And so that's 2 divided by f of x, basically. And that is 3x minus 5 divided by x minus 1. And what we can do is multiply the top by x minus 1 and the bottom by x minus 1. Because this will cancel, which is what we want. And then this, we're just going to have to distribute. 2 times x minus 1 is 2x minus 2. And then this is just 3 minus x minus 5. Okay. And that's it. This is perfect. So let's look at this. My domain of my original one is all values of x except x cannot equal 2 because we figured that out here. And we need to look at the restriction in my inner function. Remember, in my g of x, my inner function, x cannot be 0. So at x equals 0, there's not going to be an asymptote. There's actually going to be a hole here. Okay, check it out. Now, my range, y such that y cannot equal my range. So it looks like -5 divided by -1. So there'll be an asymptote at y equals 5. Since the degree of the numerator is equal to the degree of the denominator, y equals 5. And let's look at our restriction of the outer function. My restriction of my outer function is this, and y cannot equal -3. There'll be an asymptote or a hole there. Sorry, y equals does not equal 3, positive 3. And there will be a hole here also. Okay. Alrighty. So let's do this side. My domain is going to be all values of x such that x is everything except for if I set this equal to 0, so 3x minus 5 cannot equal 0, add the 5, 3x equals 5, divide by 3, x equals 5 over 3. Okay, so x cannot equal 5/3 because that'll make the denominator 0. And we have to look at the domain restriction of my inner function. So x cannot equal 1. X cannot equal 1. And that is going to be a hole. So the domain of my inner function is going to be a hole. The domain restriction of my inner function is a hole. Now let's look at the range. My last one, let's do a range. My y such that y, it looks like the degree of the numerator is equal to the degree of the denominator, so it's the ratio of leading coefficients. So there's going to be an asymptote at 2 over 3. And then also I have to look at the domain restriction here. The y cannot equal 0. So there'll be a hole here. Y cannot equal 0. All right, guys, let's graph this. It's going to look like, I'm just going to put in the asymptotes. It looks like x cannot equal -2. I'm sorry, positive 2. So this is going to be an asymptote. And the other one is when y equals 5. 1, 2, 3, 4, 5. Alrighty. And then it looks like there's a hole when x equals 0 and y equals 3. So a hole at 0, 3. So I'm going to draw that hole 0, 1, 2, 3. Okay. And you know that our function kind of looks like this. Okay. Now let's look at our g of f of x. It looks like there is an asymptote at x equals 5/3. So that is 1 and 2/3. So like, I don't know, it's like almost 2. And then there is a horizontal asymptote when y equals 2/3. So All right, I was just looking to see if it was negative 2/3. Okay, so y equals 2/3. Alrighty. And then I know that there's a hole. Where's my hole? It looks like when y equals 0, x cannot equal 1. So when y equals 0, x equals 1. There's like a hole here. Ah, it's bigger, sorry. Alrighty. Oops. Alrighty, guys, I want you to try the rest and ask me if you have any questions.